Okay, so now I'm going to go through a slightly more complicated vectors force question. So in this question, we're looking at, I've got two forces. I've got 3 newtons vertically and 4 newtons acting at an angle of 40 degrees. And I want to find out what is the magnitude and the angle of the resultant force of these two forces combined. So to do this, we've got the complication that our second force is acting at an angle, so we need to resolve the vertical and horizontal components of our 4 newtons. So to do that, to find it vertically, we can use SOHCAHTOA. So to find the vertical component, we would use cos theta equals the adjacent over hypotenuse. So the hypotenuse is the 4n, and we're trying to find the adjacent force, which would be the vertical component, which is A. So we'd use A, h cos theta equals A, which is our vertical component. So we've got 4 cos 40, which when you put into a calculator is 3.06. Then we need to find our horizontal component. In which case we can just swap our cos for a sine, as we're now finding the opposite, the angle. Which when I put into a calculator comes out at being 2.57, and that's newtons. So now we need to redraw our diagram from before. So we've got our 3 newtons from before, vertically. So our total vertical force is going to be 3 plus 3.06 equals vertical. And we've got 2.57 horizontal. So I'm just going to redraw that then for us. I'll just get rid of all this. So I'm now looking at a force which is 6.06, which is our previous force added on with our vertical component of our 4 newtons at 40 degrees. And then I also have, so I'll redraw that there actually, 6.06. Our horizontal component, which is 2.57. So now we're almost there to solving the question. So we're trying to find our magnitude, which is x, this angle theta here. So we can find the magnitude by using Pythagoras' theorem. A squared plus b squared equals c squared. So we can do 2.57 squared plus 6.06 squared square rooted. So that is found to be, got it written down, 6.58 newtons if you pop that into your calculator. And then we want to find theta, the angle of which our resultant force is acting at. And to do that, we can use tan theta equals opposite over adjacent. So we'll have tan theta equals our opposite force, 2.57 over 6.06. So I'm just going to use the inverse of tan to find that angle. Which when you pop that into a calculator equals 22.98 degrees, which is essentially 23 degrees. So we've been able to resolve our forces and find that the magnitude is 6.58 newtons acting at an angle of 23 degrees for the resultant force.